Hello, this is Mr. G, and I'm going to talk about the difference between distance and displacement. So like distance versus displacement. All right, and this is a fundamental idea or concept in physics for understanding the fundamental and basic ideas of motion. All right, so distance versus displacement. So I'm going to give you some examples. All right, so let's start off here. Example one, we're going to start off at this position right here. All right, so there's a little person. It's a happy little person. All right, and they are going to walk, let's say, 4 miles. Whoop. East from their original position. Okay, so 4 miles east. Then they are going to walk north 3 miles. And sorry about the sloppy text here. I'm kind of writing with this tablet at a weird angle. In any case, so 4 miles east, 3 miles north, and then you end up, different color, right here. So here's where you stop. And then over here, yikes, this is where you started. Okay, so distance versus displacement. Distance is what you normally think of as how far did you walk, right? So in this example, the distance traveled by this individual, well, it is, you went 4 miles, and then you went 3 miles. Yeah, so you went 7 miles. So the distance that you traveled or moved was 7 miles. Okay, 4 miles and 3 miles. Right, there you go, your average, ordinary, everyday definition of distance. Okay, displacement. That's different from distance. It's a little more precise, maybe. It's a different way of describing how you moved. So for displacement, that is the distance between where you stopped and where you started. The displacement is like the straight line as the crow flies from where you were and where you are. Okay, so to represent displacement with little arrows, like I did here for distance, displacement would be represented by a little arrow that starts off where you started, zoop, and ends up where you stopped. And so your displacement is just the distance between where you stopped and where you started. So in this example, notice here, this makes a really nice little, it's a right triangle, okay? And we know a few things about right triangles. Specifically, there's this thing called the Pythagorean theorem, okay? So the distance between your initial position and your final position, that's right here. And guess what? If this is 4 miles and this is 3 miles, Pythagorean theorem, let's call this thing d, for example, right? So d squared is equal to, how about this, call this x, and let's call this y. So d squared is equal to x squared plus y squared. That means that d squared is equal to 4 miles squared plus 3 miles squared. Let me make some more room down here. Okay, so 4 squared, that's 16. And the units are miles. You square those too. So 16 miles squared plus 3 squared is 9. And you have to square the miles also. So 16 miles squared plus 9 miles squared. So d squared is equal to 16 plus 9. Let me think about this for a second here. Oh, wait, that's 25 miles squared. And then this is now entering the realm of algebra, okay? So if d squared is equal to 25 miles squared, then what is d equal to? Easy peasy, lemon squeezy. You take the square root of both sides. All right, and then that gives you d on the left, and we'll use a whole different color here, about blue. So that turns into d equals the square root of 25 miles squared. Well, the square root of 25 is 5, and the square root of miles squared is miles. So there you go. Your displacement was 5 miles. And that's less than the distance. The distance you walked, yeah, that was 7 miles, 4 and 3. But your displacement, again, that's just the distance between where you ended up and where you were. In this example, we could figure this out using some geometry, and it is 5 miles. This is a famous 3, 4, 5 triangle. And that is your introductory lesson on distance versus displacement. Oh, wait, sorry. One more example here, okay? Check this out. All right. For extra credit, you will get a cookie if you can answer this in class tomorrow, right? So, again, we're going to start off right here at this position, okay? And then you are going to travel, let's say you go 5 meters towards the right, and then you're going to travel another 5 meters up or north, okay? Yeah, let's just use the compass directions. And they are, in case you've forgotten, never eat soggy worms. Worms are best eaten when they're really crispy. So you're going 5 miles east, and then 5 miles north, and then how about 5 miles west? And finally, guess what? Yeah, you guessed it. We're going to go 5 miles south. And then you end up right here where you started. So then the question is here, what distance did you travel? Well, you went 5 miles and 5 miles and 5 miles and 5 miles. That's 4 times 5 miles. Yikes, you walked 20 miles. That is a nice... That is
uphill both ways.
in the snow, uphill both ways. Yeah, when I was a kid, I'll tell you what, okay? My gosh. You don't know how easy you guys have it today compared to, when we were kids. So yeah, the distance you went was 20 miles, okay? However, your displacement, that's the difference between where you end up and where you started. Guess what? Okay, remember, extra credit cookies here. who can answer this? Yes, that's right. Your displacement is 0 miles. How crazy is that? It's like you basically didn't go anywhere because you ended up back where you started. So that's another example of the difference between distance and displacement. And that concludes our little lesson for this evening. So thank you very much. You guys have a great evening. I'll talk to you all tomorrow.